this video, we will talk about Makefile wildcards and pattern rules. Makefile has two wildcards, star and modulo. Let's see first for star wildcard. This searches in file system for matching file names. Let's understand with an example. Writing Makefile source file equals to star.c, taking target print, adding echo for the value of source file. Save this Makefile. Issuing make utility. It has echoed for main.c, test1.c and test2.c files. Updating this Makefile for object files also. Adding object file equals to star.o. Adding echo for object files also. Saving this Makefile. Issuing make utility again. This time it has echoed for source files and object files both. What if I delete these object files? Let's delete these object files using rm command. ls object files are not present now. Issuing make utility again. Here it has echoed correctly for source files, but C for object file. It has simply echoed the star.o as string. This we do not expect anytime. It would have not echoed anything for object files, so we should wrap it with wildcard, which is add visible. Let's update our Makefile. Adding wildcard keyword for both object files and source files. Save this Makefile. Running make utility now. This time it has echoed present C source files and nothing for object file, which was expected. Next, we will see modulo wildcard. This wildcard is used for several purposes like static pattern rule, pattern rules, string substitution, the vpath directive. Let's see the use case of module wildcard in static pattern rule. For a given list of targets, target and prerequisite are matched by modulo wildcard. Then command will be executed if matched. Now, let's understand with this with an example. ls here, I am having some C source files, test1.c, test2.c and main.c files. Let's create object file for each source file using static pattern rule. Taking variable for object files, object file equals to test1.o, test2.o and main.o. Putting all object files for compilation, all value of object files. Adding pattern rule now. Object file which contains list of targets, modulo.o, modulo.c. This will match for all C source files with object files present in list of targets. Then for each matched object file and C source file name, command will be executed. Here, this will be iterated for 3 times. First for test1, second for test2 and third for main. Adding command gcc-c $, which is automatic variable for first prerequisite, -o $, which is automatic variable for the target. Let's save this Makefile. Opening terminal. Issuing make utility. You can see here 3 commands are executed. First, when test1.o and test1.c files are matched. Second, when test2.o and test2.c matched. Third, when main.o and main.c matched. ls now all object files are present. Now we can also generate executable file from these object files. Let's update our Makefile a bit to generate executable file. test.exe list of object files. Adding gcc command. gcc object files -o target file. Saving this file. This time first rule is having prerequisite test.exe. This test.exe is having dependency on object files. This object files is again dependent on C source files, as C source files and object files are already present in directory. Only one GCC command will be executed to generate test.exe executable file. Running make utility again. This time, only command was executed to generate test.exe, which was expected as well. I will check now what happens when I delete these object files and try to recompile. Let's delete all object files using rm command. Issuing make utility again. 4 commands are executed this time. First 3 to generate object files and last command to generate executable file test.exe file. Running this executable file, we got the prints. I will go back again to Makefile and show how powerful this static pattern rule is. This static pattern rule is equivalent to below 3 rules, where it is written separate rule to generate each object file. This is how you can minimize your Makefile size by using static pattern rule. Next, we will see pattern rule and understand the difference between static pattern rule and pattern rule. Let's use same Makefile. I am changing this static pattern rule to pattern rule, removing target list here from second rule, just keeping pattern matching part. This will search for match in current directory, not likely to only search in given list. Let's save this Makefile, removing all object files. Issuing make utility. It has successfully generated object files from C source files by matching names of file using pattern rule. Now, we will understand the difference between pattern rule and static pattern rule. In static pattern rule, match is searched only for given list, while in pattern rule, it is searched in whole directory. To understand more specifically, taking another object file 1, which contains only 2 object files, test1.o and test2.o. Saving this Makefile, ls object files are not present now. Running make utility. Notice here at output for the third command, it is different from first two commands. It is not generated by second rule. It was generated automatically when no rule was found to generate main.o. It was generated by first rule automatically. Make utility has the capability to generate object file from C source file automatically with same name. Let's see what happens if I delete second rule from Makefile. I am deleting here the second rule, saving this Makefile. Running make utility. You can see here, all 3 object files are generated automatically. Next, we will see how can we do substitution of string in Makefile. This is the syntax for substitute. Keyword pat_subst, pattern which has to be replaced, replacement pattern, and text in which the substitution has to occur. Let's understand this with example. Taking source file list, test1.c, test2.c, and main.c, updating object file using substitution, $pat_subst, modulo.c, modulo.o, and source file. It will substitute C file with O file, adding phony target clean also this time. rm-rf, object file, and executable file. ls C source files are present. Calling make utility. It has compiled successfully, means it is perfectly substituted for object files. Issuing make clean. It has issued rm command to delete all 3 object files and executable file. Now, we will see the last use case of *wildcard as vpath directive. It adds the directory in which compiler will search for specific files. Adding vpath modulo h. current directory, inc directory. I had added main.h file in this directory. So, compiler will also look into this directory for .h files, saving this makefile, issuing make clean, calling make utility. It has compiled successfully. Let's see when I comment this vpath directive. Calling make clean, issuing make. It has given error this time. In this way, we can add search paths for our compilation using wildcard.